Morning. It usually does. Boredom usually leads to something very cool. In programming in particular, but in other things too.
I finished all of my code for the project, and then it was like done by the weekend, but I was so bored that I just waited to like a billion hours.
Nice.
Like I spent all weekend on it.
Nice.
The whole weekend.
Fantastic.
I don't know, down the line.
And then it breaks probably the second I go on with the presentation this afternoon.
I don't know, down the line, I might try to be snazzy and turn my thing from iOS stuff. That'd be really fun.
All right. Well, let's get started. It's 11, so we'll go ahead and say good morning to everybody here, the few and the proud who are in the room, and the few and the proud who are online as well. We've got small numbers, but we're going to make up for it with enthusiasm and lots of good questions, right? Yeah. Woohoo. How are people feeling about their project demos being, in some cases, done, or at least in some cases close to done? Yeah, okay, so hopefully we're feeling all right about that. So I will point out for everybody, we're doing the pseudo chat thing again, so please do sign on in Top Hat and say hello in the pseudo chat for the 6th of April, 2022. And if the chat doesn't work for you, let me know in the chat. No. If you're not able to see this video, let me know in the chat. That's not going to work either. Hopefully this is okay. Hopefully somebody will say good morning in the chat. Whoever it is will, the 6 of us who are here will applaud or something. Hey, they haven't said anything yet, so calm your horses. All right. Yay, we've got a good morning. Hooray. Well done. And number 2, sorry, you're just not quick enough. Okay, so today is going to be another tutorial. So we will talk about whatever it is that you want to talk about. You can ask questions about anything to do with the course, final exam. I don't promise to answer every question, such as what's on the final exam. Well, I would answer that in not a great amount of detail, but I would answer that. I would also like to take the opportunity to remind everybody that there are some things that have been posted in Top Hat. So I posted some practice quizzes and they were like quizzes that we had last year, I think, when we didn't have regular kinds of midterms. So please do those for a couple of reasons. One, it'll be good practice for you. And like all the Top Hat exercises, you can do them together. I would encourage you to try to do at least some of them by yourself to sort of check, can I do this when my friend isn't helping me? Because of course your friend won't be there in the final exam. Well, your friend will be there in the final exam, but you won't be talking to each other in the final exam. But also, like other Top Hat things, there is a credit that's associated with doing the questions, so please do those things. There's also the feedback section that has been opened, so we don't have CEQs this year, but at some point they'll come back. But in the meantime, I'd love it if you would, I'd love it if you'd leave me a rating. No. I would like and subscribe and leave me a rating in YouTube. No. So please do, though, send that feedback through Top Hat to let me know what was effective, what wasn't, what was helpful, what wasn't. Obviously, for the past 3 years, we've been trying new and different things every time we teach, and I'd like to know which of those are actually helpful to you and which ones aren't. And of course, very soon, I'm looking forward to not having this hybrid format anymore, but maybe just being people in a room together. Possibly still, doing the lecture capture thing, because anybody can be sick and miss a class, but hopefully it'd be nice to get back to, being humans together. So yes, do complete those quizzes, do send feedback, and the feedback, there are no right answers, so you won't get a correctness score. You don't have to say everything was the best in order to get points. All right, so yeah, good. So now I'm ready to answer questions. I've got a hand. Fantastic.
Is there any way that we can do those like practice quizzes again? Because I did them all, but like I can't do them again. I don't think.
Oh, really?
I
So,
don't think so. They're not there anymore.
oh, okay. So I think, So let me think about what to do there. So with the quizzes, maybe I will export the questions as PDFs because right now they are open up until the 14th of April. Once the due date passes, then you'll be able to see them for review, but that's not going to be super helpful because 3 p.m. on the 14th is when our exam begins. I left it open in case there's like somebody who at 2:45 on the 14th is like, no, still got to finish those quizzes. But yeah, that's a good point. So maybe I should export those as PDFs and then I can post those to the course website. I also posted on the course website, by the way, if you go to the resources page, there is a sample final exam. And these are actually the questions that were asked to students completing the final exam last year. 90% of students did the final online in a semi-proctored format, and these were exactly the questions that they were asked. Other students who weren't able to do that wrote a deferred exam and actually wrote it on paper, kind of like you folks will, and they had a slightly different exam. But these are the questions that were actually asked. So again, that's something that could be helpful for you. Now, every year, we do slightly different things and emphasize slightly different material. So it's possible that there could be something on the final exam that you'll say, wait a minute, we didn't do that, did we? And it's possible that there's something that we didn't actually do, but maybe we went further in a way they didn't. But still, I hope it'll be helpful for you. Make no guarantees about anything to do with it other than it ought to be somewhat helpful. Okay, cool. Other questions? Yeah, go ahead.
Any chance you could give an example of functions that are very confusing?
Yes, absolutely. We could do examples of functions. Okay, so a function, unlike in mathematics, in programming, a function, we always think of it as a machine that takes some inputs and possibly gives some outputs. It may or may not give outputs. So if I write a function, I'm going to write def. And then I'm going to write the name of a function. Let's say that this function is called say hello. So the syntax, def for define function, the function name, and then in parentheses we have some parameters. For now I'm going to skip parameters. We have a colon, and then we always have at least one statement, but that statement could be pass. So, bother, just a moment. Fine. You can see that I have an Adobe license. Who cares? All right. Yeah, so if I call this function, I'm going to run this program. It will define a function called say hello. Now I'm going to call say hello, and you see it doesn't really do anything. What value does this function return?
None.
Right. So if we said, let's call say hello, and whatever it returns, we're going to put that into a variable, well, you'll see that it returned none. And the shorthand for the Python interpreters, if you call a function or if you write any expression that evaluates to none, it just won't say anything. If I write 0, it'll say, hey, your expression evaluated to 0. Here, if I say none, it doesn't say anything. This is equivalent to saying return none. Right, so the return statement says, once you get to this statement, take whatever expression is here and return that from the function. Pull the eject handle, we're out of that function, and here's the value that our function is going to give back. Our function call will evaluate to this. We could also, in fact, just write return. And to write just return with no expression implies return none. Okay, so that's how we give an output, but let's say we're going to return 42 because, you know, that's a good thing to return, so why not? So now our say hello function will return the value 42. So this function call evaluates to 42, which means if I wanted to have a more complex expression, like 1 plus, say, hello divided by 3, well, I could evaluate that expression by one step at a time, saying, okay, 1 plus say hello divided by 3. Well, we have an order of operations here, so we'll do whatever's inside the parentheses first. So we will get the value of 1, get the value of say hello. How do we get the value of say hello? Well, we call the hello function, see what it returns. In this case, it returns 42, which means we can take that say hello and kind of scratch it out and say that say hello, open parenthesis, close parenthesis, is now replaced by 42. So 1 plus 42 is 43. 43 divided by 3 evaluates to 14.3333334. There we go. So that's how we get values out of functions. How do we get values into functions? With a function call. Yep, that's right. And so if I want to call the say hello function, say hello, Bruce. So this is an example of a what? An argument or a parameter? That's an argument, that's right. So something that we put into a function, a value that we take and pass into a function is called an argument. And where does that argument end up? So if a function's like a machine that has input slots and output slots, we put values into these slots. The value we put in is the argument, and the slot is the other word that I said that wasn't argument. It's a parameter. So let's say that our function is called say hello name. So let's be more interesting. G'day plus name plus exclamation mark. Okay. G'day, Bruce. G'day, Bruce. Say g'day to Bruce. Bruce. Sorry, that's a kids' game in the UK where, and then it's kind of, if you mess that up, then you have to move to the next name, and then you have to say g'day, Bruce. G'day, Sheila, and then you go from Bruce to Sheila to a bunch of other quintessentially Australian words. And I don't think it's offensive to Australian people. It's anyway. I hope not, because now it's on the internet, and I don't want to be cancelled. Okay. So here we go. Let's define this function say hello, and now I'm going to call say hello Bruce. And so we're going to take that argument, which in this case is Bruce, we're going to pass it into the say hello function. The say hello function will run, and when it runs, it will run with a value of Bruce in this parameter name. So in fact, let's do it this way. So we'll step into this function. We're going to call say hello. We're going to take the argument Bruce. We're going to pass it into say hello. And so now we see our say hello function is running. And our say hello function is running with a local variable called name. And its value is whatever the argument was. So we can have other local variables inside of functions. Right? I could say greeting is equal to g'day. So then we could return, for example, greeting plus, there we go. So we can have other local variables inside of a function, but parameters are examples of local variables. The thing that's special about them is that they're not initialized by assignment statements. They're initialized by an argument that goes into the function. That's what makes them a bit special. So we define functions, we call functions, we have parameters. Those parameters can have things like default arguments. So in fact, let's say that we wanted to have greeting also be a parameter. And we say that if we don't specify otherwise, that greeting will be g'day. So what that means is I can say, well, let's call say hello Bruce. Or I can say hello Sheila. Or I can say hello John. Very good. And notice here that the number of arguments that I'm passing in is different from the number of parameters. But that's okay, because one of these parameters has a default argument. The default argument means if you don't give me anything for the greeting, I'll just go ahead and use this as my default. But if I wanted to, I could say, well, let's specify that the greeting is greetings. So now it says, greetings, John. How much more dignified is that, really, in the proper RP? Or let's say, hello. There we go. Hello, John. So that's fine. So now I can specify an argument to go into that second parameter. I could also specify which parameter I want to pass that argument to using a name. So this is called a keyword argument. There are some rules here, though. So for example, if I want to say hello to John and I want to be really clear and explicit that the name is John and the greeting is hello, that's fine, I can do that. I cannot do this. Why not? What's the rule? So the keyword arguments have to come at the end of the function call. Once you start using keyword arguments, you can't go back to positional arguments because it'd be really kind of confusing in some cases. If I had a function that takes values x, y, and z, and then I say I want to call this function and pass in x equals something and then two other values, I guess they're supposed to be y and z, but it's potentially ambiguous, and we don't like ambiguity in programming. We like very, very explicit deterministic rules so that everybody understands things in exactly the same way, and we're extremely precise about it, which sometimes is annoying when you're like, why is the autograder telling me that capital N is different from lowercase n? But you know what? That level of precision allows us to speak without lots of redundancy. The English language is about like 75% redundant. You can remove words from sentences and do all kinds of crazy stuff and still figure out probably what the person meant. And programming is not that way. Mathematics is not that way. You lose one little thing and the whole meaning changes. But that means that we can construct these really elegant ways of describing complex systems relatively simply. So that's the trade-off. And that's what we get with synthetic languages. So keyword arguments have to come last. Similarly, any parameter that has a default argument has to, once you start using default arguments, then you can't have other parameters that don't have default arguments. Because again, if I wrote this, and then I wanted to call say hello, and I pass in a string, is it supposed to go to the name or is it supposed to go to the greeting? This is confusing. We don't allow that. Okay. It is worth noting that every time greet everyone names. Every time we call a function, sorry, I shouldn't be trying to think up my example and and try to talk to people at the same time. So every time we call a function, that function call has some local variables, and those local variables are separate from the local variables from any other function call. Even if it's called the same function, if I call say hello 10 times, each call has independent different variables. So like if I said here x equals 3 and then later x plus equals 1 or something, the value that's in 3 when I call it the first time is completely independent from the value when I call it the next time. So for example, let's do this. Let's use a list comprehension. I told you, you don't have to write list comprehensions, but I might have one that you have to read. So let's say the greetings are say hello name for name in names. Now what does that mean? That's kind of like saying greetings is an empty list for name in names, greetings dot append say hello name. There we go. So this line is kind of a shorthand way of saying all of this stuff. And so that's why we use them sometimes. And then let's say I'm going to return. What does this do?
Prints all the names down, I'm gonna follow them.
Yeah, so, well, not print, but you're mostly right. So \n means new line, which means go to the next line, sort of like you're typing on a typewriter and then maybe you haven't had that experience, but if you ever have, it's a lot of fun. You should try typing on a typewriter ever, and then try imagine working in a room where like 30 people are using typewriters instead of using computers, and wow. And people didn't even have like wireless headphones to put in and listen to their music. It was, we have to have respect for those older generations, our forebearers. There used to be a typing pool in this building upstairs in what is now the Associate Dean of Undergraduate Studies office. So the undergraduate office plus the dean's office, there used to be a big empty space in the middle with a typing pool. And that meant there were people whose job it was to take like handwritten exams that professors made up and type them onto carbon paper that could then be put through a mimeograph machine to duplicate 100 exams. And we don't do that anymore, but that's the way it used to be. So tappity tap tap tap, very loud. So this is saying we are going to join a bunch of strings together, and between each of those strings we're going to stick whatever is in this string. So this is the join method of the string object. So now if I run this and let's print. So the one quibble is that we didn't actually say we were going to print anything yet. We're just creating strings. Now let's actually print what happens when we greet everyone, where everyone is, let's use a tuple instead of a list. Bruce, Sheila, and yeah, I won't try to get any more stereotypical because maybe I would become offensive. I'm not sure. You have to be a little bit careful because you never know what people are sensitive about. I have met lots and lots of people who knew I was from Newfoundland and thought it was okay to call me a Newfie because they thought they were being friendly. And it's like, yeah, no, not so much. So you never know what things are a little bit sensitive. If we were better friends, you could call me a Newfie, but we're not, pal, so don't. Anyway, so we're going to call the greet everyone function. We're going to pass in an argument, which is a tuple that contains two names, Bruce and Sheila. So Bruce, Sheila, there's a tuple. We're going to pass that into greet everyone. So we start running the greet everyone function with a parameter called names, and that is initialized to this tuple. And now we're going to execute this list comprehension. So we are going to say for each name in Bruce and Sheila, we're going to call say hello. So the first name was Bruce, so now we're calling the say hello function with name being equal to Bruce. And I set this value of x to 3, so I have a local variable, which is 3 plus equals 1, so now it's 4. So you'll notice we have 3 local variables, greeting, name, and x. And the value of x is 4. Now we are going to return this expression, which is g'day plus comma plus name plus exclamation mark. So we're going to return g'day, Bruce. And so we return that. Very good. Then we call say hello again with another name. And look, not only do we not have a value of x equals 4, we don't even have a variable called x anymore. Because when we finish that first function call, all of its local variables out the window, just completely gone. So that local variable x is no more. Now we have a new variable called x. And so that's really, really important to keep in mind, particularly when we have things like recursive functions, where functions call themselves. And earlier someone asked me if I could write a recursive function. And yes, I certainly can. So I want to make sure I'm not ignoring the chat here. There is a question in the chat. Is the final going to be hard? It's not intended to be, but I guess a lot of that will depend on you. I genuinely believe when I write final exam questions, they'll require thinking, because ideally I'm asking you to solve a problem that you haven't seen before. Because I had a conversation with a student actually this semester, and I thought they put it really, really well, which was that once they understood what they were supposed to do in the problem and how to solve the problem, all of a sudden the question was really easy. Like actually answering and writing the code was really easy once they had figured the problem out. But the hard part was figuring out the problem in a way that the computer could understand. And that's a really, really good way to put it. So for all of these questions, in some sense, the questions should all be really easy once you've figured the problem out. And so the difficulty sometimes is figuring out how I can ask a question that you've never seen before, a problem you've never solved before, in a way that you will be able to understand and that doesn't have any miscommunication, which is partly why, sometimes that misfires a little bit. So more people were confused by the last question on midterm 2 than I meant to be confused. But unfortunately, that happens sometimes when you have to ask a completely novel question every time. It's not like take this truss, rearrange it slightly, and put different numbers on it, right? So, what was I saying? Oh, right. So is it going to be hard? So the questions aren't meant to be hard. It is the sort of thing where if you're practicing a lot now, you should genuinely find lots of questions on the final exam to be like really straightforward. And there should be questions where you say, is that it? I feel like there should be more. Like I should have to work harder at this. If you're practicing writing code a lot now. If you're trying to figure things out almost from first principles on the fly in the exam, then, well, you'll need lots of time and you may indeed find it difficult to complete in time. But if you're practicing writing code now, you shouldn't find the questions difficult or intimidating. There'll probably be a question where I ask you to solve a problem which requires stopping and thinking, but that's okay, because I would suggest you have 180 minutes, figure out how many minutes that is per point when you get into the exam and say, all right, here's how I'm going to pace myself. And ideally then, do the easiest questions first, right? Figure out which questions am I most able to answer quickly with confidence, etc., so that I'm not going to have to go back and triple check them, etc. And then you can say, oh, look at that. I budgeted 20 minutes to do that, but it only took me 10. Cool. Now I'm ahead by 10 minutes, right? And then you can feel a little more confident when you get to the question. You say, by the points on this question, I'm going to need 45 minutes for this one. I've actually got 55. So, okay, I can afford to give myself 10 or 15 minutes to stop, take a deep breath, think about the problem, try to work it out by hand in a couple of different ways and say, all right, what's the essence of this problem? Oh, okay, now I see what I can do. Now I can write some pseudocode or draw a flowchart or something, and now I can turn that into Python, etc. So it shouldn't be hard, but part of that will have to do with your confidence, which has to do with your preparation. So back to recursion. So if we want to write a function and you will see lots of functions with metasyntactic names like foo, bar, baz, and wibble. There's no particular significance. These are just names that are commonly used in programming when I don't want to say what the function does. Because I might have a question where I say, here is a function, what does it do? And if I gave the function a proper name, well, it would say what it does, right? Divisible sum. Well, this calculates the sum of some numbers that are divisible by something, for example. So if I write a function called foo, and then this function says, if n is equal to 0, return 42, else return foo of n times 3, or something like that. So there's a nice, simple recursive function. So let's debug this. Step over all that stuff, define that function. Now let's actually step into this. So we're going to call foo of 3. And so this foo function has a parameter called n that's initialized by the argument of 3. And so I would really suggest, if you're doing a problem like this on the final exam, and the pressure is on and you're thinking about the time, and you try not to think about everything else in the world, but sometimes you end up thinking about lots and lots of things. Try to focus so that you don't freak yourself out or panic or whatever. However, I would suggest it'd be really handy in that circumstance to write things down clearly and explicitly. So in this case, I'm going to write down that I am calling the foo function, and I'm passing the value 3 into it, which means that I have a variable called n, and n is equal to 3. And then if somewhere in the context of that function it changes the value of n, if n times equals 2 or something, okay, well, I'm going to change that to 6 maybe, but then I will keep track of this functions, local variables, and maybe it has an x, maybe it has other things. Maybe, like on the midterm, there's a global variable that's also in play that we need to think about, something like that. But when I call the next function, I'm going to keep track of, okay, I'm calling foo of, in this case, was it 2? Oh, that's a bad recursive function. We'll come back to why in just a moment. So I'm calling foo of 3, which means that I've got a foo that has n, that has 3 in it, etc., etc., etc. And actually, like, draw, here are the local variables for this function call, here are the local variables for this function call. When you finish a function call, you could say, all right, you know what? We're done with that function now. So I'm not going to get confused. So when I look at what is the current value of n, I'm not going to say, do I mean this n? Well, no, I'm not going to be confused because I have crossed that out. All right, and I know that this thing returned such and such a value, and this thing returned such and such a value. Maybe this returned 12 and this returned 24 or something like that. Do feel free, by the way, if you want to bring colored pens or pencils or whatever. Some students bring highlighters and they find that's helpful, because if I have a design question in which I say, here's a bunch of information, now you need to understand this problem and then write some code to solve something related to it, well, it might be that, you know, highlighting key bits of that problem is helpful. If that works for you, great. If it doesn't, that's fine. All right. However, we did, in fact, just then, as I was drawing things and showing where numbers are going, we did see there's a bit of a problem here. What's wrong with this function? This will never end. Yeah, so that's always a good guess. What's wrong with this recursive function? It's an infinite recursion. That's probably like a 50%, guess. In this particular case, I didn't even mean to make an infinite recursion, but look, my professor's question posing just can't stop myself, apparently. Foo of 3 is calling foo of 3, and then that foo of 3 is going to call foo of 3. And that foo of 3 is going to call foo of 3. And that foo of 3 is going to call foo of 3. Yeah, so we're never actually going to stop here. So this is an infinite recursion, and that's bad. And did you notice how there are all those different little windows of here's one foo call, here's another one, here's another one, here's another one. They all have separate variables. So much foo. Yeah, we're going to be full by the end of this. All right, so can you review tuples, arrays, and dictionaries? Yes, I sure can. So we have lots of collections that we can use to store things, and in fact we've seen 3 ordered sequence type collections. We have seen lists, we have seen tuples, and we have seen arrays. And to initialize an array, actually, we're going to pass in something like a list or a tuple. I better import numpy here. There we go. So what's the difference among these 3 things? Tuples, lists, and arrays. They do have differences. They all, in some ways, behave the same way. Right? So for n in L, print n, that's going to kind of have the same behavior. Oh, it's going to take a minute to load numpy. Oh, yes, and I have that recursive call, so let's comment that out. And did you notice, by the way, although that was an infinite recursion, it actually only infinitely recursed for about half a second, so not really all that infinite. However, it did call foo several hundred or maybe even 1,000 times in the span of that half of a second before Python said, you know what, never mind, we're done here. I'm not making that many calls for you. I don't like you that much. So here, if I say, let's iterate over all the values in L and print them, or all the values in T and print them, or all the values in A and print them, we get the same result in all 3 cases. So why would we want 3 different ways of representing these things? They're all ordered sequences. So the answer is they do have slightly different semantics. So a tuple is much simpler. So if I run this, how many methods does tuple give us? Well, we're going to ignore lots of these things that have underscore, underscore in them, etc. Mostly these exist to service operators. So like underscore, underscore GE is a method that helps implement the greater than or equal to operator. So that allows you to say things like, is T greater than or equal to T? Yes, it is, because T is T. So you don't have to know about those things, but for those who are interested in going a little bit further, the underscore hash method is something that we use to hash a value so that we can put it in a dictionary. So we said that keys have to be hashable. Well, that's actually done using a method called hash. Surprise! Underscore str, something that we use to turn values into strings using the str function. So it's helpful. But you'll notice the only two methods of consequence that we actually care about, which in fact, let's do it this way. So method for method in dir of t if not method dot starts with underscore. There we go. That's a nice little list comprehension. So you'll see that the only two methods that we really kind of care about here are count and index. That's it. Whereas if we look at a list, okay, now a list has a bunch of methods that we might care about. We can append to a list. Why can't we append to a tuple? One answer would be, well, because it doesn't have an append method. Well, that's true, but there's a philosophical reason why a tuple doesn't have an append method. What's that? It is not mutable. So a tuple is an immutable data structure. We cannot change it. A list is mutable. We can add things, we can remove things, we can change values in the middle, etc. And a NumPy array it's a fixed sized list. We can change the values inside of it, but it's represented in a way that's much more memory efficient and much more high performance, and is really good when we have lots and lots of values of the same type and we want to do mathematical operations and stuff, which is why it's in NumPy. I don't expect to ask you any questions in which you're going to have to write code where the difference between a list and an array is significant. So we're not going into those levels of detail. Now, I might very well have a question in which I say, what's wrong with this code? And the answer is you're trying to modify a tuple, and you're not allowed to do that. So that would be fair. But we're not going to get into like the really fine details of the difference in the semantics between some of these things, like lists and arrays. You should know what the point of an array is and why it's different, but I'm not going to like ask you to write code where the difference between a list and an array is important. And so if you want to use an array, or you want to use a list, or you want to use a tuple, in a lot of cases you can use whatever you like. We also have sets, where we don't count on ordering. And what's the other special thing about a set? So if I have a set, 1, 2, 3, 1, 2, 3, what values are in S? For n in S, print n. What's that going to print? Just 1, 2, and 3. Actually, let me change this to not cause confusion with the other thing being printed just above. Now we only have 4, 5, and 6. Why is that? Right, so sets don't allow repetition. If you add something to a set, it's in that set. If it was already in the set, then it's already in the set. I could construct a set from my name, and you'll see that the result is, well, a string is something you can iterate over, so you can pass it into a set. And you'll see we have a bunch of characters, but although there are lots of O's in my name, there's only one O here. And also, we make no promises about the ordering. So a set is not a sequenced, it's not a sequence, it's not an ordered collection in the same sense that these things are sequences, they're ordered collections. It's an unordered collection that doesn't have any repetition. So that's what makes sets useful. And then finally, we can have dictionaries, which are also quite useful. So if I were to have a dictionary that contained songs, just a second, so this might be near and dear to the hearts of those who are working on assignment 5, that optional assignment. Oh, we've got hands up. Yep. Right, so Ah. Oh, come on. Letters equals. See, I am also bad at typing when it's in front of a bunch of people. So if I say, what is letters 1? Right? It's true that you can't index a set, but why is that? It wouldn't really make sense to say, what is element 0 in the set? Because the set doesn't make any promise about things being in the same order that you put them in, or even the same order that they were the last time you looked at them. When you add new values to a set, that could potentially change the order in which you find the values that were there before. So it doesn't make sense to talk about element 2 or element 7 because the ordering isn't important. So sets don't let you talk about them in terms of indices. Yeah. Question here, or is it the same one?
You kind of covered. I was going to ask if there was any kind of rhyme or reason to the order that the sets fit out the
Yep. So there is a rhyme or reason, not one that we're going to cover here, but I'm happy to tell you that in order to put things into a set, it has to be hashable, just like a dictionary key. That hash code is something that can be used to construct an ordering. So you can say that I am storing these things in the order of their hash code, but the relationship between the hash code and the value you can actually look at is not something that is easily predictable. In general for hash functions and for cryptographic hash functions, which is something that I care more about, and which is the fundamental technology out of which like blockchain-y things are based and cryptocurrencies. Pardon?
Are you on the blockchain?
Yes, I'm a digital object, and I am on the blockchain. No. Yeah, NFT me. Yeah, well, we can have a conversation later about that if you like. There are issues there. Blockchain technology is like 98% sensible technology, and then 2% let's build more coal plants in outer Mongolia. And say, wait a minute, hang on now. So yeah, there's lots of useful things about blockchain stuff, but we have almost all the same usefulness without calling it the blockchain, and then you don't get all the crypto bros who are like, dude, have you seen my ape? It's really... Anyway. Sorry. There are topics that can get me going. It's kind of like I had a 4th grade teacher who, if we didn't want to talk about social studies that day, we'd say, "Sir, what happened during the war?" And then he was good for the rest of the period, and we could just do whatever we wanted. Anyway, sorry, Mr. Vincent, if you're watching this. Okay. Yeah, we didn't even specify which war. What happened during the war? Right? Okay, so if we have a dictionary of tunes, we could say, well, here is the name of a tune, and then here is an actual tune in the format specified. So this has got lots of extra spaces, which is kind of unfortunate, but anyway, D, 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 right? So I could have keys, which are like the names of songs, and then the values are actually the contents of the songs. Or I could have keys which are student numbers, 2001, 25805, and the contents are like tuples of name and grade in the course. 97. Hooray, I'm giving myself a really good grade, apparently. That would be a conflict of interest. So, it's interesting, actually, sometimes even when faculty members have kids who go through the engineering program, there'll be like things that are put in place where they'll ask somebody else to mark a few of the exams, including your kids, just to make sure that you're not being unfair. And it's usually not unfair in the good direction. It's usually that you have to stop faculty members from imposing a higher standard on their own kid and marking their own kid more harshly than everybody else's, which is, I don't know. What does that say about academics? I'm not sure. But a dictionary allows you... Sorry?
There's a whole new form of combo.
Yeah.
From Rocky Road.
Right? And sample student is doing better than I am in the course, so that's great. So a dictionary is something that allows you to map keys, where those keys have to be hashable, which means, among other things, they have to be immutable, to values. And we can have any type of values we like. We can access the keys in a dictionary by calling the keys method. We can access the values by calling the values method. We can access the items, where an item is a pair of a key and a value, by calling the items method. If I iterate over, so for something in D, print something, what's that going to print?
Well, print none because there's no something in D.
Well, so this is iterating, and we are defining, here's a variable name that we'll have, this is our loop variable. So every time we go through the loop, there'll be something put in that variable called something. And it will be, are we iterating over the keys, over the values, or over the items? When we don't specify keys, values, or items, what do we iterate over in a dictionary? The keys. Right, so this will print 2001, 25805, 2020, 12345, which I don't believe is anybody's actual student number. Probably not. I have before, running like official reports from the registrar's office to import data into our admission systems, found students name things like test student and student number 12345 and stuff, and I'm kind of guessing that that's not a real person, but I don't know. Sorry, test, if you're out there and you didn't get promoted to term 3, then you can come back and talk to me if there really is a person named test student. Okay, so that's tuples, lists, arrays, sets, dictionaries, which is what someone asked for. Can you go over the concept of name and main? And by the bolding in the question, I can see you were probably asking with underscores in front of it. So, Python will define for us a variable in every file. Why don't I put it that way? Called underscore underscore name underscore underscore underscore. And that name will contain some kind of a name that we can look at, which will either be, if this is a file that we have imported as a module, it will be the name of the module. So if okay, I'll come back to that in a sec. Alternatively, if we're running the file as a script, then the name variable will contain a string which has main in it. And that lets us know this is not being imported as a module, this is being run as a script. Which means that, for example, something we might do, if name is equal to, main, then we might run some tests here that we don't want to run if we're importing it as a module or something like that. So when I run this, I see main. If I import temp, you'll see a temp at the bottom of it, because when we import a file as a module, the name of the module is what goes into this variable called name. Does that clear that up? Okay, good. What kind of questions can we expect from topics? Real number, integer representation? Yes, we can expect questions on those. I mean, I think I said that, and you'll see, for example, on the final from last year, there was a question where I said, given an integer, can you convert it to a sequence of bits, for example? Turn it into the binary representation. That's something you should be able to do. I'm not going to require you to have memorized, well, if you're converting this real number into a 64-bit IEEE floating point number, then you need to have 1 sign bit, 11 bits of exponent, and the remainder are the mantissa. No, I'm not going to expect you to remember that. The fact that we represent floating point numbers with an exponent and a mantissa, or the fraction component, which is represented in a fixed point way, that's fair enough. I'm not going to expect you to remember all the details of 32 versus 64-bit floating point numbers, etc. But you should know something about how computers represent floating point numbers, and in particular that they actually use integers to represent floating point numbers is kind of interesting. Okay, any other questions? We're coming to the end of our time, so I guess that's a convenient place to stop. Yep.
Are we going to know matplotlib for the final?
So for matplotlib, you won't have to know lots of like finicky matplotlib details, but you should know that it has a function called plot that lets you plot x values against y values and x values against y values and x values against y. So, and I might show you matplotlib code that includes things like axes which have titles and a figure that has a super title and stuff, but you won't have, and you might look at the code and you might look at the plot and say, yep, those things line up. We're not going to ask you things that are really finicky matplotlib details. Yep. Sure. So let me see what I had from last year. So on this sample final exam, now I think for this exam, I think there were 120 points available, or sorry, 180 points available, and there's 180 minutes, so you could guide yourself accordingly. If we come down to the end, and here's the reference method or information. I was like, remember, here are some methods of list. Here are some methods of string. You don't have to memorize all of those. Yes, the stuff was given. So here's an example of something that was 24 points. So I think I probably, if this was added up to 180 points, which I think it did, then I would have expected you to take 24 minutes. You should add up all of the totals. It might have been that actually this was only 100. I'm not sure. So, well, we can. So 40 plus 50 plus 20. Okay, so it was 110. So I would have expected you to spend a half hour or more on this, for example. Which means you've got a few minutes to stop and think about, okay, don't panic. Don't panic. How am I going to do this? What is involved? What are the steps? If I do this by hand a few times, what are the steps that I just saw myself taking? How could I describe those as steps in a procedural abstraction, etc.? Or how could I describe that in a procedure that has very simple operations that I could use to explain to the computer? I will see if I can drum up another example of an even longer final exam question. I think this one was an unusual environment. The trouble is the year that we switched to Python is also the year that the pandemic hit. So I don't have any normal final exams for 1020 that I've given that use Python. I have a bunch from C++, but that wouldn't be particularly helpful. But I'll see if I can drum something up that was an example of a longer question. Yeah. So I would say that, practicing programming more is good. I would say find something that would be kind of fun to do, whether it's hopefully your project is something that is of personal interest to you and is not just something that you have to do, but it's about something that you actually kind of find fun. See if you can extend that. In the next steps lecture, I gave a few examples of things that you could go beyond and play with a bit more. So doing a little bit more practice is good. There's no specific preparation you have to do or anything, but the more conversant you are with all the first year stuff and the more confident you are with all the first year stuff, the better it'll be. And I mean, you can, if you want to, look into C++. Strostrup has a great book, C++ Principles and Practice, 2nd edition. He's the guy who created the C++ programming language. And unlike some textbook authors, he's not just in it for the money and creating a new edition of the book every 12 minutes. It took him 15 years to come up with a 2nd edition. So, and it's actually pretty good in terms of helping you learn. So, yep. All right, so my battery is about to die, and we are getting to the end of the time, and I'm supposed to be talking with a grad student in 7 minutes in my office, so I think we'll call it a day there. Thanks very much for coming, and we'll do this again on Friday.